Hello friends, welcome to my channel. In this video today we are going to discuss about coroutines in Android. So the quick agenda for the day is what are the coroutines, how they are related to threads, and how to create a simple coroutine and run that coroutine inside our Android application. So we are going to cover all of these things today. So before understanding coroutines, let's first understand how our Android application is running. When we launch that Android app, what is happening behind? Okay, if we understand that, we can clearly understand our coroutine concept. Now consider I am launching Gmail app. Okay, so what is happening when I tap on the Gmail menu icon? Android OS is creating one main thread for that Gmail app. The thread name is main thread. Okay, that is only one thread for that app. Every application is going to have only one main thread. So inside that main thread, our entire Gmail application process is running. So entire life cycle is there inside that main thread. Now that main thread is going to be a very lightweight one. If you perform any time-taking process inside that main thread, it will be blocked and we quickly end up with this error message, application not responding. Why this is happening? Our main thread is a lightweight one. If we perform any network related operation or database read-write operation directly inside our main thread, we quickly end up with this error message. So if you want to remove this error message, we need to move our time-taking process from main thread to separate thread. That is why threading comes in. Okay. Now, using threading, what we can do? We can perform this time-taking process using a separate thread. Okay. Now, what will happen? This separate thread is running parallel to the main thread. Our main thread is there. Separate thread is making an API call to the server, or it will call data from database, or it will write data into database. Now, our main thread is free. Separate thread is doing the time-taking process. So after that time-taking process gets completed, the thread post the data back to UI thread so that UI thread will render the data accordingly. Now our UI thread is free, our separate thread is doing the time taking process. Now we can simply get rid of this error message using threading concept. Okay. Now understand what is the problem using threading. In threading also we have lots and lots of problem. First problem, memory leak. When it comes to running a background thread in our Android application, consider you are launching a thread inside our activity. Okay, you are finishing that activity. What is happening? Whenever you are finishing activity or going back from one activity to another, right, at that point of time our activity will be removed from memory, but the that is running inside our Android application or inside our activity, right, that will not allow our activity to be cleared from the memory. Because of that, memory leak is happening, and sometimes this may crash our app. We need to fix that error. That is memory leak issue. Okay, first problem is the memory leak. And second problem, switching from background thread to UI thread. So whenever your time taking process gets completed, we want to post the data background thread to UI thread. So switching from background thread to UI thread is the intensive process, so that we need to avoid. And if you want to create multiple threads, right, we can create, but problem is in the Android environment every application is limited to run some limited number of threads. If you run more number of threads, multi-threading environment comes in, and still lots of developers are struggling to handle multi-threading environment because communication from one thread to another using lots and lots of callback is there, right? That is difficult. And if your application, consider your application is allowed to run 10 thread, and you're creating if you want to perform more than 20-30 operation at that point of time, what will happen? We want to create some logic behind, right? Some thread scheduling we need to create, or queuing mechanism we need to create. So using this concept we can get rid of that multi-threading environment issues, but we can do, but this is difficult for developers. And when it comes to a chain of request, okay, thread multiple chaining a multiple threads, at that point of time also we have to use lots of callbacks. For example, I'm performing one network operation, that is getting some result. Okay, using that result I'm making another request, that is coming up with some response. Now using the second response I'm calling third thread, that is coming up with some response. Now what is happening, this kind of chaining is there, right? For this chaining we have to create lots and lots of nested code. along with that lots of interfaces. So what will happen, we lose code readability in this place. So to get rid of all of these problems, we have only one concept, that is called coroutines. So coroutine is a pattern. Okay, coroutine is a pattern that we need to follow in multi-threading environment to create efficient threading mechanism. Now let's see what is our coroutine. So when we create a coroutine, right, lots of people confusing coroutine with threads. So do not confuse, coroutine is not a thread. So what is coroutine then? Coroutine is a job that thread going to perform. Okay, so when you create a job, actually we are going to create, when we are creating a coroutine, we are actually creating a job for the thread. Because in multi-threading environment, if we create lots and lots of thread, we have to handle it in a separate way, right? Thread scheduler or not, we have to create. So to avoid those kind of problems, coroutine already have set of thread pool. So we are not going to create a thread. Coroutine itself is having a list of thread pool. Now we want to define our job and we want to dispatch our job to any of the thread pool, so that any of the thread inside the thread pool will complete our job. So this kind of architecture is there, right? This is what a pattern. So coroutine is come up with some pattern. Inside that pattern, what is there? We are going to create a job, not a thread, and then we are going to dispatch this job to a set of thread pool, and any of the thread from the thread pool will take care of our job and then post our result back to UI. So this is how our entire coroutine is working. So lots of people are confusing what is thread, what is coroutine, right? So do not confuse. Coroutine is not a thread. Coroutine is a pattern. If we follow that pattern, we can write efficient multi-threading code. Okay, using coroutine, we can create efficient multi-threading code. Now let's go back to code and we'll create one simple coroutine. So we have an activity here, and inside that activity we have one button. Now when I tap on that button, I'm going to start one coroutine. So to enable coroutine in your Android application, go to your application Gradle file and add this line to your dependencies section. Coroutine Android, I'm using 1.5.0 version. So once you added this, sync your project, and once your project sync completed, and we can make use of that coroutine inside our app. Now I'm going to call one coroutine. Okay, I'm going to create one coroutine. So global scope dot launch, that's it. Okay, now we have created one coroutine. See how it looks like, very simple. Inside our coroutine we can launch our job. What is our job? Some API call, threading dot fake API request. So as we discussed already, using a coroutine we are going to create a job, right? See, this is a job. Now we have created a job and we have to perform this job, right, under any of the thread. So how to say this job to be taken care by thread pool? Okay, lots of thread pool is there. So under which thread pool we are going to run, that we need to pass as a parameter after launch. Okay, by default it will take dispatches dot default. It will take dispatches dot default. It means like we have three thread pool. One is default thread pool, another one is main thread pool, another one is IO thread pool. We'll discuss this more about dispatches and thread pools later. For now, use IO thread pool. So we have created a pattern. Okay, actually using some pattern we have created a job. That job is dispatched to a IO thread pool. So inside our IO thread pool, lots of thread is there. Using any of the thread inside this thread pool, our job is going to run, and then it will post the data back to our code again, so that we can take a decision from here. So this is how coroutine is working. So what is coroutine? Coroutine is a pattern to create efficient multi-threading code. So this is all for this video, friend. In our later section we will discuss more about what is global scope and what are the dispatches are there, and how to get the data, how to just simply call fire and forget request and all. We'll discuss in our upcoming session. Okay. So quickly recall what is a coroutine. Coroutine is a pattern to create efficient multi-threading code. Coroutine is not a thread. So that's all for the video, and I hope this video will be useful for your friends. Thank you for watching my video. Let's meet in our next session.